Okay, so maybe we want to wait for some, maybe we want to wait for a while in case some other guys would be joining. All right, let's get started. Hello, everyone. Super excited to have another community meeting. So today I'm going to share something. Okay. Hi, guys. Hi. Can you hear me, Eric?
Where are you, Marco?
How are you, Eric?
I am walking my dog and I'm going to go on mute. Sorry about that, everybody.
Wow. What's his name?
His name is Marco.
Marco.
Now that I opened the door.
Hi, say hi to Marco. Welcome to the community meeting.
Come on, Marco. Come on. This is Marco.
Hi, Marco. Wow. Wow, he's so cute.
I think so. I think so too, but I'm a prejudice.
Oh.
Thank you. My first meeting. Welcome.
Welcome, welcome. So maybe you can introduce yourself later. Hi, Lindsay.
Okay. Hello.
Hello.
Can you hear me?
Yep. So maybe the network's flapping. I see Zhong is joining. So we're having a party. This is the largest meeting in history. Yeah. Okay, let's get started. So as usual, I will give the brief introduction of the agenda. So we will have introduction of the newcomers at this time, formally. So maybe, and then I will give you a brief update of the project's news. And today I prepare a ad hoc topic later. And finally, we can have open floors to have a sync discussion on any things you would like to bring. And maybe we can introduce ourselves first. So Eric, could you help introduce us, you and Marco? Yeah.
Perfect. Yeah. My name is Eric Laquer. I don't care how you pronounce my name. I'm a data engineer, but a fairly long career, 40-year career. I've spent the last 7 years specializing in market logic, which is a multi-model database. One of the models is Graph. So I've done Graph at scale, implementing kind of big systems like healthcare.gov is based on this technology. So it's just some LexisNexis, some pretty big stuff. And I'm looking to be able to bring this technology at a lower price point to smaller clients. That's it.
Wow, cool. So very nice to have you. And I see you are very experienced in graph domain than us. So it's great to have you. Yeah. Lindsay, how about you?
Okay. Hello, everyone. My name is Lindsay. This is my first time attending this community meeting. And actually, I just joined NebulaGraph last week. So I'm still learning graph database, and hopefully we can see each other in the future and see my growth in this field.
Cool. Welcome.
Okay.
Welcome.
And, thank you.
Yeah. And finally, Zhong, could you introduce yourself to us?
Sure. Thanks, Wei, for hosting this. This is Zhong Tian, coming from China, Beijing. I'm also a new member of the NebulaGraph family. So I'm so new to a graph database as well. My past experience has been on the cloud space. So hopefully I will learn a lot from you guys. Thank you guys.
Thank you. Okay, so let's continue. So I'm super excited. We have so many people this time. So we will have this this meeting bi-weekly, and everyone can join. And if you want to bring some topics to us, it will be fantastic. So just let us know before the meeting anytime on the Slack, or you can put things on the Etherpad. So everything can be found in the Slack or the wiki of the community repo. And yeah, I will start with the project Heartbeats. So we are very close to another release cycle, which is maybe in upcoming 1 or 2 weeks. And this time we have a bunch of PR being merged massively in last 2 weeks. And most of them this time are addressing the optimization and the performance. So there are basically no new functional improvements in this time. And there are a bunch of bug fixes that I didn't highlight here, but some other improvements I can quickly go through. If you are interested, you just dive into the repo. And so the first page is around the Nebula core. So the first one is around the find path. So when you are finding shortest path, this optimization is quite interesting. So you are actually doing the BFS from the 2-point starting and the destination point in parallel. So but when you have even number of the shortest paths, so it will be different. That I'm not going to dive deep, but we precisely removed the actual get property execution to make it a little bit more performant when you are doing shortest path finding. So the second one is optimization regarding when we have the input property or variable property. So there are difference of them. The input is actually a pipeline, and the variable is like you declare a variable equals to something, and then you give a comma and another sentence. But either way, there will be an improvement now that we instead of query the data from a property name, now we make everything in a tuple and get data during the execution from the index of the tuple. So because it's actually immutable, so this is another performance improvement. Next thing I want to highlight is that we bring a bunch of configuration that previously they just hide it in different sort of codes, and they were not properly documented. And now we bring together of them and into the default configuration with a properly relatively meaningful default value. And this is the conf change PR, but I consider it's very important. So there are a bunch of match related optimization. So there are some of them are push down the vertex filter, push down the edge filter, push down. And this is a bug fix that I put it because I contributed this. So yeah, and this is the optimization rule that's removed a useless actual project when the rule is applied. So it's kind of helping the performance. And this one is more complicated that I couldn't understand the details. So if you are interested, you can check out. And the final one is actually just documentation that one of our old contributor provided this because we noticed a lot of users were not tuned their operating system in the best practice. So he contributed this guide with a TuneD configuration. So TuneD is actually a Linux utility, a binary package that you can easily make some tunings on top of operating system. So his guide is quite easy. So with the configuration on the TuneD afterbox, you can run 1 or 2 commands to have your operating system in a better starting point. So and that's more compatible with the Nebula Graph. And that's all of the core part. And regarding the other surrounding two chains, one of them is the Nebula Agent. So Nebula Agent was a standalone agent that's helping some of the. Initially, we bring this to Nebula because we want to make our backup and restore working better. Previously, we designed it in a not that elegant way. We coupled with the SSH, so it's not optimal in containerized environment. So we introduced the agent to make the backup and restore easier and fancier. But in future, we may put more things on it. And when you're putting the workload on Kubernetes, and it will by nature to be one of the sidecar. And this PR is bring the incremental backup capabilities. Previously, we can only do the full backup. So second one is regarding the client side that last week, our community contributors, WJJP and me, I helped a little bit. So we make our Node.js package finally compatible with v3 Nebula Graph core. And he also even make the publish and the unit test connected with the UT. So finally, previously, because this is not a officially sponsored repo by Vsoft, so we didn't make it quite polished. So I sometimes contribute on it in my free time. And now the publish can be done automatically as well. Previously, I do it manually, which is ugly but work. The final one is this is a working in progress PR that's which is I consider worthy to be shared. That this is related to when you want to generate SST files. So that will help you to generate the underlying file format of the Nebula. So you can do T+1 huge amount of data. For example, user like WeChat. So they want to make a lot of data every day. So in that time, you can choose to use SST and sideload the information in your Nebula Graph. So this will save your cluster from computation on sorting the data. That's sometimes it will impact your online service. So with SST, you can make these efforts on your Spark infrastructure or on cloud ad hoc in an ad hoc fashion. So the issue here is previously we actually inside of Nebula, when you're doing this SST thing, you need to hash some of the keys. But in our core side, we are hashing it we are using one of the famous hash algorithm called MM3, but we change it. We didn't use the vanilla one, and when we are creating the exchange, we don't have this context, so we use the vanilla one. So in a corner rare case, so it's there like for a year. Finally, some of our users hit this rare condition, and we figure out, and one of our contributors fix it in this PR to use the exactly same behavior when it's doing the hashing in the core part. So it's quite interesting. And finally, I would like to share my ad hoc topic today. So it's related to some of the work I have done around the data lineage and the metadata management. So I will introduce the Amundsen. It's another open source project to our community. And some background. So what is metadata governance system and what is data lineage? So from my understanding, I think most of you already have a sense on that. I just give a opinionated explanation from my side. And I think so the metadata governance is actually about controlling your data to ensure the quality, and you have to build trust, because if you don't have you lost the track of the context of all your data's metadata, you don't know when you can change it, or you can delete it, or you can do some work on top of that, right? And also you need to make everything in a single source of truth to everyone can query and check it, instead of like everyone have to fan out a large email loop, or check how ping everyone in a Slack group to see, hey, is anyone know something about this table and this oops. So anyone knows something about this table and this column, can I delete this view in this database? So that will waste a lot of communication. Hi, Eric, welcome back. So that will waste a lot of efforts in communication. So what is data lineage? So this is an even more fancy word, right? So it's more about the traceability of your data. So the data and information flows in all life cycle, from how it was generated from raw data, and it can be consumed by other application service, or regenerated by another table, another view. And there will be a batch or streaming pipelines to talk to the data. So everything should be controlled processly to have a guaranteed performance, right? And why do we need that? I think the what part already explained the reason, because data grows, and even we have only 2 people in a small team. So you're from day zero, everyone know who is in charge of which table, and you have all the history in your mind. But when your team and data grows, you don't know which data belongs to whom, and you cannot guarantee your data quality, and you need the lineage to be managed. So instead of putting everything in the outdated, loss of sync wiki pages, or you occasionally add some comments in your database when some of you change schema. So it's not a trust data working environment. So we need to, ideally, we need to bring a single source of truth of all the metadata, and including the data lineage. So and that's why I'm trying to make this reference projects. And this is one of my opinion, because I was witnessing a lot of community users. So when they are asking about a query, and I noticed their query is about data lineage. So I realized a lot of people were recreating their own wheels to make their own toolings around the data lineage. So I want to help. So maybe I can leverage some of example schema, or leverage some of the open source projects. So and make some study. And it turned out, I found that instead of creating a standalone service dedicated for data lineage, we should instead leverage a whole metadata management system, because the lineage is actually generated from the metadata. So when you extract it, you are actually talking to all the other metadata of your data lab. But why not manage them together? And if you have 2 systems, you have to make the consistency between the lineage data and the source, the metadata. So if possible, I suggest we have everything in one system. And luckily, we have this open source. I really love it. The open source project called Amundsen. So it's initiated by Lyft data team, and it's donated to Linux Foundation. And a bunch of big and small teams are using them, and they are contributing to the project. And it has a very great data module and API. and a fancy front-end interface, of course. So this is the official website of Amundsen. So basically, you when it comes to the front-end interface, you can have this single source of portal. You can search, starting from the search, everything is indexed. And when you are searching some of the table, some of the column or dashboard or pipeline, all the metadata are listed here, and you can manipulate on top of it. So everyone is seeing the same thing. And there are some statistic of all your data, owned by who is the frequent users. You can tag things with specific meaningful tags, something like that. So everything is connected and beautifully controlled in the system. I will give you more sense on how it looks like in the demo in the end of the topic. So, but I want to give you more idea on how they module the metadata and the lineage. So it will make you making more sense, because we are all graphers, right? And I choose one of the image from their very ancient version of their data modules. This is like the day one module. Is quite naive, and you don't have too many things that they already support in now, but in our time. But I think it's more easier for us to fresh users to understand. So basically, they I hope you can see it clearly. So they module the components like database. And database has a cluster. Cluster instance can have a couple of different schema. And your table instance belongs to a certain schema. You can tag the table, and the table can be generated from a Airtable DAG. And you will have every single column managed separately in the system. And you have a user can read something and can own the table or other components. You can have the description separately. There are a lot more of them nowadays in Amundsen, but just this is just a reference for you to make sense of how it looks like leveraging the graph capability. So yeah, this is how it looks like in the architecture view. So basically, there are only two parts of the Amundsen. It's quite easy. One is in charge of extracting or ingestion all those metadata, including the data in lineage things from different sources. So they can be different databases, data warehouse, or some other utility. I can show you more, but this they don't draw too much types of sources, but there are more of them. And they have a bunch of data builder things to support the mainstream data sources afterwards, and you can even can custom them quite easily. They abstract them beautifully, and underlying they persistent data in a single source of truth in a graph database, and they leverage elastic search for the full text search. And the other part is the service part. So you can either query its metadata API, underlying is calling the graph database, and of course you can search. Or you can do it from the front end. I will demo you their front end GUI service. So yes, here is the demo. So this is actually a Amundsen running on top of Elasticsearch and Nebula Graph. So you can search here. For example, you search test, and you have a bunch of different resources. You can bookmark it here. So it has a lot of different useful information here. This is the owner, the quality related information. You can ingest and integrate with the data quality service here. And this is the metadata. So you have everything here, and you can read or write on top of that. You can tag your metadata. And this is the data lineage. So there is one upstream of that table. So this is jumping to its upstream, and you can see all the data lineage in the graph view. So it's quite interesting, but there are more of that. I just review some of its cool features, and but it's on top of NebulaGraph. So what we can do else with the NebulaGraph, right? So I think this is maybe one of the reasons why Amundsen choose to put data only on a graph database, because most of the graph database by nature will offer you explore a data visualization tool. So the meaning here is everything you want to explore or you want to get insight from in your metadata service, it's actually a web service, right? You have to define your new API or new GUI. But when you are running data already on graph database with the something like NebulaGraph Studio, you can have another console visually to get your metadata or lineage insight. Just to click your mouse. So you can optionally imagine you are leveraging NebulaGraph and Amundsen. You can optionally expose your studio to the people who knows what they are doing, so they can have those metadata insight on their own in this beautiful way. It's quite and plus on top of this, you can also expose your graph query interface to them. So it's like your DSL for your metadata or lineage system. You don't have to write your code to bring on new APIs. You just expose your graph database interface. Maybe you limit it to a read permission. So that will be quite beautiful. I'm not going to walk through everything I recorded already, but basically you can query the metadata in your visualization providing from your graph database like this. So I think it's cool. And what's underneath? So actually underneath there are just a bunch of graph queries, right? So this is the code from the Amundsen, and this is a Nebula proxy that I contributed to enable the capability of Nebula as a backend. So when they are calling execute table query, so underlying is this giant match query. And if you change the code into an actual query, you can actually make it towards the Nebula graph. So I'm proving I'm not cheating. So you can see this. This is the beautiful part of the graph database. So in the single query, you are fetching a bunch of information in one go, and in no time, it's quite fast. You actually query a table and with the ID of this this VID, and optionally you are already matching another 10 different patterns in this one go. And finally, you want to process your return values in a format that your API would like to see finally. So it's beautifully done with this pattern. And yeah, so enable to help to introduce Amundsen to our community better, I actually created this reference project, and this is the article describing that. So in this project and article, I want to dive into details, but I want to give you a bird view of what I have provided you. You can do it very easier. So I enable to have everything connected in a detailed way. I actually set up a whole data stack. So I'm a newbie to data stack, so please don't laugh, Eric. So maybe it's quite naive. I actually bring a dummy database. I choose to use Postgres as your data warehouse, your database in our lab. And I bring a data ops utility with ETL, and I also I put a BI tool into this stack, and also a job orchestration, which is the Airflow, and finally the Amundsen. So in this project, I put everything runnable, so you can just copy and paste and run everything on your own Docker environment. So firstly, you can run this chapter to have your Postgres in the container, and you will have some dummy data inside, and then you will run. I use Meltunnel, which is a beautiful open source project leveraging the Singer for its extraction and the loading, and use DBT for the transform. So I make this connected to help you generate some data source from a CSV and to your database, and make some transform of your existing table in the first place, in the first step too. So you will have a relatively a toy data set. So then I bring the Apache superset to this stack, and I even create a bunch of very naive chart to become a dashboard. So it looks very ugly, but it's a dashboard anyway. And finally, I bring the Amundsen together with Elastic and the Nebula. You use one go, everything is up in the Docker Compose. And I give some examples with the data builder to load some dummy data in your system, so you can click and check everything inside. And finally, I create runnable examples on how you actually make every source of the stack as your metadata source. And I create the example of the running jobs, so you can make everything from the Postgres, the DBT pipeline, and your even dashboard. So every component inside the metadata component can be extracted in my reference projects. So then I bring the superset as a preview of the data of the Amundsen. And finally, here is the final example to help you extract the lineage information from the DBT manifests. So it's a genius combination. So if you have the luck to leverage DBT for ETL, so you don't have to write your own extracting rules you can just put together everything. You can extract the lineage to your system. Of course, you can write your own one. So it's quite, frankly, it's quite easy because they have a beautiful abstraction on doing that. And so there are a lot of details in this article. It's on my website and the Nebula official blogs. It's just posted today, if I recall correctly. So, and if you want to talk about it, this whole project is also on GitHub. Feel free to PR and issue me. Yep. And finally, let's do a recap of this topic. So with Amundsen on NebulaGraph, so we don't have to struggling or put a lot of effort to recreating the views. So you just need to connect with it. There are a bunch of extractors. You can bring most of your data components in your lab, your data center into Amundsen, and you can extract the lineage with DBT. And everything is running on NebulaGraph, so you can use your competence, your experience on what you can do on NebulaGraph already. And if you want to write your own data lineage extraction jobs, so it's quite easier. I didn't mention that every the data builder jobs can be managed by either like Open Function, some other serverless infra, or you can run on Apache Airflow in a DAG orchestrating way. And this is how everything is connected. Sorry, I have to move here. So we in this project, I consider everything in this data stack as a metadata source. So we use some Amundsen data builder to extract those information. I have all the examples in my article and the GitHub. And afterwards, it will be persistent in NebulaGraph. And you will run another jobs to make the index from the NebulaGraph and inject the index to Elasticsearch. And afterwards, you can have the beautiful interface with Amundsen frontend, and everything is connected. So that's all of these reference projects. So, and future work. So actually, the effort on bringing Nebula Graph to Amundsen is still working in progress. I make the POC and even passed all the UT code, and the PR is like 10,000 of lines, but still the RFC is still under discussion and review of the Amundsen community. So, and in future, I want to, after it's merged, finally, I want to bring more unique concepts of Nebula to this Amundsen community. And as I mentioned, we in my example, maybe I can here in my example now, everything is based on the pooling module. So we are actually running our jobs to pool the metadata. So maybe in the future we can leverage the serverless capabilities, or for example, from the Knative or Dapper, you can do some event-driven thing. So maybe I can make some example to, like, you can like add a webhook. When you change something, the webhook will call a function, and the function will help you extract some metadata. So that's doable. And finally, that when I was doing this work, so Amundsen is Python based, I realized that our Python SDK, a Python client, isn't perfect on the user experience perspective. So in the future, when I have some bandwidth, I will refine it and maybe bring some more abstraction to Nebula Python. Hopefully I have some time. So that's all of the topic today. Any questions or topics we want to discuss, Eric?
I'm really impressed by this. This is fabulous. I was actually looking at this from the direction from a couple different directions. I was researching Amundsen independently of my exploration of so I'm feeling like I hit the jackpot here. This is beautiful.
Oh, really?
Thank you.
Cool. Thank you. Thank you. Okay. So and welcome again to the Nebula community. So feel free to reach me and other guys in Slack and GitHub. And so, yeah, maybe let's call this a day. Thank you so much for joining. Yeah. See you next time. Stay tuned. Bye-bye.